Uh, Hi Nikita and Raj.
Hi Praveen, hi, how are you?
I'm good. I'm good. Thank you. Hi, Nikita. Okay.
So let me share the screen. We will. So Raj, how is the preparation?
Uh, Not so well, busy with the work, but trying to catch up whatever I can.
Mm, okay. We will do one thing. You guys know these things, or you are not sure of? Okay. What we will do is, my plan is like, if topics are not available, then we will go through the questions. If we know, we will solve it. Otherwise, we will skip and go to the next one.
Yeah.
So that's the only option available. Should we start with the sample paper shared by the professor, or the previous year questions?
Uh, I think anything which has got answer would be okay.
Yeah. Actually, I was waiting for Panimalari. Hi, Panimalari. She's available, I think, every day. She told.
Mm. We were doing this in our first semester, Manoj, if you remember.
Yeah, yeah.
Yeah, yeah.
Okay,
So
let's
the
see.
answer paper in the DL, okay, just now Nitish shared, right? That's really good. Okay. It's written well.
He written well, or is it?
It's I don't know. That paper is really good. How many percent turns required for the required to represent, and then computational graph for the equation, and then what? Yeah, XOR gate implementation. Yeah, nice. Good.
That, I think that the same thing I have mapped today. Today, what I did is I spent 3 to 4 hours for mapping the each question
Hmm.
to each file. Oh, this is a different one, right? Oh, this
Uh,
is
you,
same. Yeah, okay.
you did an what do you say? The 4.5. I mean, all the handouts. You put it in that. That's the one.
No, no. Today I shared a new drive link where all the questions were separately put into each file. Actually, I'll show you the folder.
Okay, okay.
So here you see all the questions are separately put into each file, so that we can solve it and upload into this same file. If you are having, so each person can have their own name into it, put their name and solve that question. No, only about 38 questions are there. Already I
Mm.
solved maybe like 4 or 5, so maybe 33
Mm.
are there, right? So each
Oh my
person
God.
takes one or two, right?
Mm.
And
Mm.
we can solve it one by one. And if the steps are there, then it will be useful as a reference for the exam. If nothing is
Okay.
possible during the exam, no. Yeah, that was
Right.
that was a plan. Yeah, what he shared is also good. I think that the same thing is available in this one. Maybe, yeah, we can go through one by one. You want to
Right.
go through
Right.
that, or but that's not having the answers, no?
Oh, it has got answers, is what I'm
Okay, okay,
seeing.
okay. I'm seeing it actually. Yeah. Let us try this.
Yeah.
How many perceptrons are required to represent W XOR X, XOR Y, XOR Z? The traditional method, number of variables is equal to n.
Yeah. So that 2n minus 1 number of perceptron, and then the alternate method perceptron is 3n minus 1. So 2n power 1. So that is 15. That is 9.
2 raised to n minus 1, where n is the number of variables, right? So variables is 1, 2, 3, 4, right? 4. Okay, so this is 15, and in this way we need only 3. That's what the answer is. Anyone knows this?
This is as per the formula, Manoj, in the XR in the study PPT. If you see, there are two formulas. Okay, there is one formula which is 2 power n minus 1. Another one is 3n minus 1.
Here they mention traditional method and alternate method.
Yes.
In the traditional method, this traditional formula is given, and we are getting 15 as the answer, right? The alternate method, there is 3 layers. First layer is W XOR X, and the second layer Y XOR Z, and layer 3 is A XOR B. So we need each one will need 3, right? So we will need 3 into 3, so that will be 9. But again we need to add them, right? That information, okay. W X Y Z, okay, yeah, right. And the output is given to okay. So in this way we need only how much? Let's
so you see how many perceptrons? 9 perceptron, 1 to 9.
Right. This is 9 only, yeah. This is a common sense thing, yeah. This is using common sense, because we can use split this one and then this one, and then result of these two can be odd, right? Yeah. So this is a formula given in our PPTs.
Yes, it is there.
3n minus 1.
Yeah. Number of layers equal to width equal to.
Okay, that's good.
So this layer finding is also, you can see it in here. If you have 2 log 2 power 4, that's 4 layer. We have 4 layer in here.
Oh, okay. One thing more. This formula is only for the XOR stuff, or what?
Well, because everything is the OR gate that put the W cross X. So that's for the XOR one only.
Let me open the lecture slides. I think we have the merged 1 to 6 is there, 1 to 8 is there. Yeah. Okay, so let me search it. 3n, right? 3 brackets n. It's not there. So number of y of why this is not there?
You'll be there in the X. Just search for the XR.
XOR. Okay.
Yeah, it's just below this. Yes. There will be a truth table. We search for 3n only.
No, maybe 3 raised to n and all. It's very difficult to. Okay, we will go with that. I think this is okay for the maybe, or we have to search on the internet, or anyone knows this here?
Yeah, Manoj, go to page number 236.
236, yeah. Let me check 236. Ah, see?
Uh, right.
Thank you.
Yes.
Thank you, Nitin. Yeah. Wonderful. Yeah.
But this is a solution. Just below, before that, there will be a formula also.
Traditional method, 2 raised to power n minus 1 is applicable when there is a limit on the depth. So
Yeah.
in this case, only one hidden layer and one output layer will be there in traditional method.
Oh, so you
But
mean
in case of but in case of alternate method, when there is no limit on the number of layers, then this 3 n minus 1 will be applicable.
3n minus 1 is applicable when there is no limit.
There is no limit on that number of layers. But in the traditional method, 2 raised to power n minus 1 is applicable when there is a limit on the depth. So only one hidden layer and one output layer is there.
Yeah, it will be more horizontally big size.
So it will have the more width.
Yeah, the layer will be only two layer, but here we are increasing the layer, so the depth is increasing.
So in this case, the number of layer is 4
Correct.
in the second case.
Yeah, but anywhere it's mentioned 236. Okay, anywhere it's mentioned this formula with that what you said, so we can have a reference to that.
Actually, it is there in the PPT, Manoj. I don't know we are looking at the right PPT, but in one of the PPT, it mentioned the truth table of XR and things. There it is mentioned the formula. We were looking that for our quiz. Hold on. Okay, there will be another big size XR table.
Truth table was also covered in the webinar.
Maybe in this PPT is not there. No?
No, PPT, I think it is also there. I think lecture 5.
I can't find. Okay, so it is. We have to mention here something. Maybe I will open it in the. So this formula 2 raised to n minus 1 is applicable for one hidden layer, right?
The classic method always have one hidden layer, and the alternate method we increasing the hidden layer.
Okay.
You can mention one hidden and one output layer.
Here is multiple hidden layers, right?
In this case, multiple hidden layer.
Okay. And what the width? Width means what? Which is number of perceptrons in a one layer, right?
Yes.
2 log to 4. What is it? 2 log to n. N is the number of layers. So we have hidden layer 1, hidden layer 2, hidden layer 3. So
And hidden layer 4. Output is also considered the layer.
out is also considered layer. Okay. So
Only output is not considered in layer.
number of layers actually. Yeah.
So number of layer is including of the output layer also.
Output and the input, right? Okay. This is in
Input, output, hidden, all.
Input,
yeah.
Input we not consider, except input all the hidden layer and the output layer is considered.
No, this is a input layer. This is also considered then, right?
So A1 this line, and then A3, and then A7 and A9. So these four are the layer.
Okay. Is including okay, so this how
See,
will you
not,
calculate this
not
two
in
leg?
a include input is not included.
But this is input, right? Or what?
No, input is WXYZ.
Input,
All layers including output.
including input layer. No, it's not input. Input layer.
All layers including output and except input.
Hmm.
Actually, WXYZ is the input and
So
A1
WXYZ, the first column,
and A1, A2, A4, A5 is the first hidden layer, and A3, A6 is the second hidden layer. A7, A8 is the third hidden layer, and
then
A9 is the output layer.
that is also considered as a hidden layer in the network.
This A1. No?
In no, A1 to A9,
Hmm.
A1 to A9 considered as hidden layers.
First hidden layer. So you can write all layers including output
All layers including output. Yeah.
except input layer.
But A1 is considered.
In this example, WXYZ. Ignore the WXYZ.
Okay. Okay. So I think this is understood, right? So we can move on, right? But how will you calculate this 2 log n2? 2 log log 2 log 2n, right? So log 2 of n. How do we calculate this log 2 of n?
Actually, n is the 4, so 4 is 2 raised to power 2. So log 2, log base 2, 2 raised to power 2, it will come to 2.
So here can we find log 2?
No, it's simple. No? So 4 divided by the base of 2, it will be 2. Then 2 into 2 is 4.
No, in all the way it will not be there. For example, if it is instead of n equal to 4, if it will be 6,
Hmm.
then, then directly it will not be 6 divided by 2. We have to take the square root of 6, then the whatever value is coming, then we have to take as a ceiling value and then multiply by 2.
Okay.
Now how do you take log 2 of 4? How will you take it on this one?
So you can take the square root of 4. So
Square root.
square root of 4 will come 2.
So that's a log 2 of n means square root of n. It's like that.
Square root, yes, yes. So square root of then multiply by 2. So square root of here n is 4. So square root of 4 is 2. So then 2 multiplied by 2, it will come 4.
Yeah, if you put 6, it comes 5.16.
Yes, yes. So the we'll take the ceiling value, so it will come 6.
Okay, so let me write it. So
Can you come again? We'll take the log 4 to the base 2 means square root of 4, isn't it?
log
Ah,
base 2,
Yeah,
right?
square root of 4, yes.
Base 2, so it
Minus
will come
square
square
root.
root of
No, log 4 base 2, sir. It is log 4 base 2.
Base 2.
Log 4 base 2, which means square root of 4. This is correct, or log A by log B? Log 4 by log 2, which one is correct? I get confusion.
Sorry, what? Log?
No, you can go ahead.
If you have a scientific calculator, it will be very easy. You can directly use that.
Yeah, but this one is what do you say? This one is scientific, right?
even Excel sheet also we can calculate.
Yeah, okay. But here, how will you do?
It is Whatever base is there, raised to that should equate to whatever the number we are trying to find the base. So here it is 2, so 2 raised to 2 is 4. If it is log 10 something, then it should be 10 raised to that should be equal to the number.
Yeah.
If it is natural log, then natural e raised to that number should be equal to whatever we are trying to find.
Okay.
The log and exponential are, I mean to say, it is raised to that base and then the number should be.
Okay. Fine. Yeah. I think everyone knows. So then we'll go to next one. Yeah. Thank you. This one. Assume draw the computational graph for the equation function of w comma z is equal to 1 by 1 plus exponential of w0 x0 plus w1 x1 plus so the bottom of the equation function of 1 by so assume that w0 is 2 x0 using the computation graph show the computation of the gradients. The answer is not there, right?
Manoj, this question was solved in the webinar 3. Not fully, but at least Professor explained the approach.
Yogesh, you are here. Thank you so much.
Yeah, hi. No problem. Because I was going through the webinar 3 and he took this example only. He didn't solve the complete one, but there was another similar example he solved, and it is a similar way we can solve it actually.
Okay, so for example, can we solve it somehow? This I think is the loss function that's given, or what?
No, f of wz is the standard formula screenshot.
Yeah.
Regarding what this formula is a loss function in the fine. Oh yeah, this is a function, right? Output. This is a loss function then, right, or what?
That's a sigmoid.
Sigmoid function. Yeah, it's a sigmoid function.
Always keep this tabular column handy. I just put that in a group. Okay, if you can open that one, Manoj.
Yeah, sure. Yeah, where did you put?
Yeah, just in the chat I put Teams chat. Yeah. It's loading.
Yeah. This will be helpful actually.
Yeah. This one screenshot you can look at. Okay, it is an sigmoid or tan or ReLU linear activation derivation range. You can choose. So the problem that what we solve is sigma of x equal to 1 by 1 plus e power minus z.
Yeah, and z is nothing but w into x, right?
Yeah, so the multiplication of the variables. So w0 x0 plus w1 x1 plus w2.
Exactly.
And then we equate everything, then you will get the value.
Yeah.
So
Manoj, if you see, right, the inputs given are w0 x0, w1 x1, and w2.
Okay.
So just replace the value.
Exactly. W2 here is the bias, and w0 x0, w1 x1. So we can formulate in the same sigmoid function. And if you see right, first see w0 x0, correct? If you see the first part of the graph, it has a multiplication there.
W0 all the red color is a reverse. Okay, just look at reverse. Only color. Yeah, so just look at blue color only. So that's the forward propagation, and then all the red color is the backward differential calculus.
Exactly. Yeah. What I would suggest now, this is a little bigger one, right? But I have gone through webinar yesterday, and the example is similar, and the way he explained also very well. I mean, once we understood this one, right? This is not difficult actually. Yeah. So yeah, you said correct, Praveen, right? Praveen, you said correct.
Yes.
The blue ones, blue ones is the forward propagation, and then red ones is back propagation. We have to go one by one. Yeah.
Okay, so we just want to replace these values here, and you will get the answer. That's what.
in the forward propagation that like we are getting 0.73 and how we are taken the backward propagation, what equation we are getting on this F.
We have to calculate at each step. So what example in the webinar he mentioned, right? See the output of W0 X0, right? There's a multiplication, right? First,
Yeah.
and output, if you see, it is -2, correct? Because W0 value is 2 and X0 value is -1, correct? So the
Yeah.
multiplication will result in -2.
So, yeah.
So what we can do is, no, we can create some intermediate variables. So after multiplication, whatever result we'll get, right, this -2, let's call it as A, correct? Then
Okay.
similarly, W1 X1, the multiplication below, just below that, the multiplication value is 6, right? Let's call it as variable B.
Yeah.
And then the next step, the summation, right? So -2 plus 6, right? So let's
Yeah.
call it as C. So likewise, for each step, right, for each neuron output, name it some variable, right? A, B, C, D, E, F, like that.
Mhm.
And
And
then
then,
first we have to differentiate that.
exactly. So we
One
have a
result.
function
Yeah.
F,
Yeah.
Okay.
probably the 1.37, right? Or
Yeah.
1 point, yeah, that is something you can say G or something, you can have some variable. So you have to differentiate like uh, df by dg, correct? And
Yes.
you have, yeah, and then you have to again differentiate the previous one like I, right? So di by dg, and you have to come back to chain rule back to w actually. So if you see w0, before that you have to calculate a, right? dw by dw0, correct? And then once you have everything, you have to apply the chain formula. Ultimately, what we are really interested in to calculate df by dw0, correct? But we cannot calculate, so we have to go from
Calculate
one
the
step at a
equation.
time. Exactly, chain rule you have to
And
apply.
finally, we are applying the values of
Exactly.
K.
Exactly. What I would suggest, no, I mean, I'm just explaining very high level, actually, just so
Mhm.
that you guys will understand the flow. I
Yeah.
also haven't solved it, but in the webinar, he explained very well. And what I'm explaining, it's the same thing he actually explained.
Mm.
Praveen, if you can also add something else that
Yeah.
might be helpful.
Because I am also looking at not the mathematical part and the overall part. What had to happen is you see this
Mhm.
minus 0.2, which
Mhm.
is coming as a backward propagation value. We pretty much use that as a learning for a weight for the next sequence. So we continuously do this subject to do the weight update.
Yeah.
Can any of you solve this and send? We can add it on this one then.
Yes,
Yeah,
I
I
on
can
think that.
Google.
Yeah.
try that. Okay, I will try that. Yeah, so
Yeah.
maybe solve this in a paper
Yeah,
and
Yeah.
I can try and bring tomorrow. So let me test this.
yeah, yeah.
I think Praveen, Manoj has already shared that link, right? Google Drive. Once you solve and
Yeah.
just tally your answers with this one, if it is correct, right? You can just upload, even if it is not correct, say, you can
Mm.
still upload. At least, our friends will at least, I mean, we,
Yeah,
we
yeah.
all will know how the approach is like, likewise.
Actually, I also felt this one first very difficult, and
Yeah.
then like point we had to put this variable and we start doing the reverse differential calculus to reach that way. That
Correct,
was
correct.
easy, and I mean, I was looking for some online based one which can help us to construct this tree and put the
Mhm.
values behind. There are some online tools also available. I'm trying to explore. So in exam, you just need to fill it. No, that's it.
Correct, correct, correct.
Yeah, yeah. So yeah, that is one thing. And will they give this graph, or do we need to write this
No,
graph
no,
as
we have to build this graph. They will
We
just
need
give this.
the graph.
Yeah.
well? Okay.
See
Yeah. How
example,
to
see the
build the
question,
graph as
see
such?
the question, draw the computational graph, right? So they
Yeah.
have given the equation and the values for the input and weights, right?
Yeah, we
But
have to draw
they're
that.
asking us to draw it actually. And if you see the, again, if you see the webinar, right? He has taken a couple of questions. So the based on the
Which webinar
question,
is that? Okay, third
oh yeah,
webinar you said.
see, there are three webinars, right? for the
Uh-huh.
deep learning first webinar, I don't think it is anyway helpful for this exam, okay, because it is completely assignment related, like a notebook and code, okay.
Okay.
You can go through webinar 2 and webinar 3,
Three. Okay.
and it is not like 2 2 hours. I think the first second
One
webinar
time.
is hardly 45 minutes or less than that,
Yeah,
and the
it was
third
one
one
time.
also like that. But I will say now, I strongly recommend to go through it. Same thing, this is same example he took, exactly same example.
Yeah, yeah. But in a different shape, I think.
Yeah, actually no, he took us some similar example, okay, he solved it completely, and then this example he started and he just explained how to go about it.
Mm.
But if you go through that webinar and just do the same thing on your, yourself also, right, you will get a
Yeah.
feeling actually. If you just listen to the webinar, you might feel you understood, but I would recommend to try it
Software
just the
by
same
yourself.
thing. Exactly.
Okay.
Can I just add two three things? The
Yeah, please go
first
on.
the first things which can be seen is the importance should be seen as to what is the function given. Like here, as brought out, this function is a sigmoid function. So as per the function, the graph will unfold.
Yeah,
We should remember that as per the function which is given, based on that the graph will come. If you observe, the
Acha,
graph
okay.
is
Okay,
made
got
based on the function that is. If the function is changed, the graph would change accordingly.
the
change.
graph will
Yes,
change.
yes.
Yes.
Okay,
Yes.
let's
Sec-
Okay, so yeah.
See, if you
To
second
see, yeah,
point
second
it
point
as
is Second
yeah,
point is, if you see, they have purposely removed W2 and they have removed X2. So
Oh,
if somebody does not observe that, then the complete graph changes. So that is where they are, just trying to. The forward propagation is very easy. It's the
yeah,
backward propagation where the differentials have to be found out is little
yeah.
integrate,
yes.
which if the solution is made available, I am sure we'll all be benefited.
Good.
okay.
yeah, but the
Yeah,
forward.
actually, yeah. To deduce the graph, I think here W0 X0 is a product, and they have given a product.
Yeah,
W1 X1 is a product. They have given the product,
yeah,
and the W2 is a sum. So
yeah.
directly they have given it to a sum of these
And
sums,
then, and if you see,
and
then they
then
multiplied by minus
exponential of
one.
-1. Yeah.
Mm.
No,
So
no,
By
no.
that
They
is
first,
that,
no, the first is minus one multiplication there, and
yes,
then
yes.
whatever result
And
you do
then
the exponential. Yes.
exponential,
Then
and
add
then
one,
adding 1 to it, and
and
then
then take
doing
a
inversion
exactly,
1 by
exactly,
x,
exactly.
and
See,
it
I don't
shows up.
think based
Okay,
on the equation, I think it's not difficult to build a graph. Okay,
build this graph.
so
Yes,
that will give
yeah,
you at least secure you maybe a couple of marks, right?
yeah. So
Yeah,
this one, I think the based on the equation, we can build this graph.
yeah,
Forward prop also easy. The derivatives part is the little tricky.
exactly. Yeah, yeah.
Oh, okay,
Yeah,
okay. Yeah. Thank you so much. I am getting the idea now. Yeah, based on this, yeah, W0 X0 we
yeah,
are
yeah.
multiplying, and
Yeah, yeah,
W1 X1 again we are multiplying, and
yeah.
W2 we are adding. But why we are adding here? We can add it here itself, right?
No, no, no. If you see
No,
there,
no, no.
W0 first you have to calculate, right? So multiplication of W0. See the denominator, Manoj. See the denominator
Yeah, I
in the
understood that one. Yeah,
yeah.
but my question is, yeah, we are having the plus sign here, right? So
No, no.
we
If you
can
see
put
right,
this.
first W0 X0, right, and then W1 X1. You have both, right? Then you combine them, right? So W0 X0 and W1 X1. That is a plus first addition sign, correct? Then you are also adding W2 with the result of the first sum.
No,
That's the
there is no brackets here, right? So we can add it here itself. That's my question actually.
Yeah,
no,
okay.
no.
W2 doesn't
That,
have the X factor. It doesn't have
Yeah,
a X
it's a
factor.
bias. It's a bias term
It's a
actually.
bias only.
Yeah.
Yeah, but why can't we add it here? I mean, is there any reason, particular reason that we cannot add it here, or?
No, but you'll not get that equation, right? If suppose if you add there,
Hmm. Because you can
uh,
see that there is two one adding and again one adding. So there is no brackets that this should be added first and this should be added next, right? So we can add it all the
no.
three inputs here, right?
I don't know if if it is like happens in the building neuron, okay, neural network.
Yeah.
That might be my primary
Yeah,
guess.
I also had that question, but
No,
somehow
I'll
some.
just clarify. Can I
Yeah,
clarify?
Sure,
if
sure.
you
Please.
see, if you see, this is 6 minus 2, so it becomes 4, and you are adding minus 3. Then it is becoming plus 1, and then there is a multiplication by minus 1. So this sequence is correct. If you still want to add this minus 3 to plus 4 here, it is getting added same place.
Yeah, it
You can
can.
Yeah, it
add
would be the
these three
same.
here,
Hmm.
but please ensure that this is minus 1 multiplication. So plus 1 can directly come from minus 2, plus 6 and minus 3. It will still come to plus 1. But this is a better representation of the graph. Probably you'll
Yeah,
fetch more marks. That is it.
correct. I
Yeah,
Yeah,
don't
still I
think
am
so.
correct.
still trying to
Mm.
understand because there is no brackets here. Why we are adding the W2 as a different stage? I mean,
It is
Actually, I
just to
think you can
show
add
that
it.
Uh,
it is just to show
You
Clearly.
the
can add.
multiplication clearly and better explanation of the problem. That's it. Otherwise, you can add it. There is no
Yeah,
issues.
Yeah,
both
there
are
is no
just the
harm.
plus
Yes,
symbol.
both
Okay,
are
there
same.
is both are same. You can put it in one.
Mm.
It is never treated as a second layer, huh? By the way.
Yeah, yeah. This is never treated as a second layer. The same thing only. Correct. Yeah.
It's just for the, I think the simply we can easily understand from the equation and the math. Okay, yeah.
yeah, because here if you do the add and again you are adding, then there should be a brackets here. That's my question. Actually.
I think you know what. One clarification I can add here. If you look at the back propagation part, right, the second part, there I don't know how we will do it. If you add these three things together, no, then we have to also like handle it accordingly because now you are coming like back propagation, right? Next step to previous step, right? One step at a time. So Manoj, if you do three terms sum together in a single sum, so that way we just have to handle accordingly. I don't think that will be a big difference, but as
Okay.
someone
Yeah.
just pointed
Yeah.
out,
Yeah.
it
Right.
is
Right.
just for the simplification.
Yeah,
Yes.
that's right. Yeah, that's a point actually. Yeah, because we
Yeah.
can add step by step by step like that. Yeah.
Step by step.
Yeah.
Yeah.
Maybe
Yeah.
that's one reason. Yeah. Yeah. For so that the backward propagation can be simplified. Yeah.
Yeah.
Okay. Thanks for that. Yeah.
But again, no,
Yeah.
look at the
Yes, yes.
webinar actually. That
Yeah,
will
yeah.
give a clear
I,
idea. Yeah. Yeah.
I
Okay.
think definitely in these two shapes, okay, one is construction, another one is putting a draft. So these two problems would come
Yeah.
straightforward. No, there isn't anything that they can make it complex. Otherwise, some of the, if you look at the question, they can ask you any of, sigmoid or something else different, but this kind of question would be there.
Even I what I guess no. So they have
Yeah.
given this equation, right? What if they just tell you the draw the computational graph for the sigmoid equation? Like they
Right.
haven't they don't give equation,
Yeah.
so we have to come up with equations, right? I think so. I mean, in case probably they might come back with such a question also, where we have to uh, give the equation and then build a computational graph on top of it, and then do the forward and back propagation.
Okay. Okay. Yeah.
Yeah.
Good.
So yeah, Praveen, so you will be doing this by tomorrow, right?
Yes, I'm gonna try that one.
Yeah.
Okay,
Fine.
whatever
Fine.
wrong or whatever right. Okay, I will try that.
Right. Right.
Yeah, I
And
will also give a try this one. Yeah,
okay. So
we'll
Praveen and
check.
Yogesh will be trying, right?
Yeah,
It's better always have two people, no?
Because one problem, even anybody wants to try on a paper, then they will get the grip on hand.
Yes, 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 yes.
exactly.
Right.
Yeah, yeah.
But there are so many problems to solve, so we will divide the problems among ourselves, and tomorrow we'll come
Okay.
after solving them, and we can discuss them. Yeah. So the next one is refer to the figure below that implements the XOR function for a Boolean Boolean input x1, x2. Bias values are indicated within the nodes shown as circles. Step activation function is used in all nodes such that output 1 and when input is greater than or equal to bias, otherwise 0. So the okay, what is the smallest value of w that can be realized? The XOR function.
So x2 is given.
Do you all feel it's a I mean it's a dim one now, right? I think the sharing. Okay. Yeah, got it. Sorry. XR function from Boolean input x1 x2. Manoj, this one is the tabular column, truth table based.
Truth table thing, yeah.
Yeah, yeah.
X bias
So
value or
if
indicated
both
with
are
the.
one or both are zero, output will be one, right?
Uh,
So, which means this is an XOR function, right? I think the question what they are asking is when we expand the equation W1 X1. Sorry, am I interrupting you?
no, please go ahead.
Yeah, I'm just trying to understand based on this thing. Okay, when we expand the equation, right? W1 X1 plus W2 X2 and given to this bias thing. Okay, and here it went to like this, right? W1 x1 plus into W2 x2 multiplied by 2 times. That is the third one. Okay. So for this thing, they are asking to give the XOR what is the minimum value. Someone figured it out 0.5. That one we have to derive, right? Okay. So the first thing, right? First equation what will come? W1 x1 plus W2 x2 plus W0, which is a bias. Okay, and it is, let's say it is greater than 0. Now it is going to 1.5. Here the values are given as 1 and 1. Now the second, it goes to the output layer also. This second part, which is multiplied by -2, which is going to the output part. So that's why they have given in the below equation, if you see wx1 plus wx2. Can you go a little up on top of the page? Whoever is sharing the screen.
Yeah, please.
Yeah, can you go a little up to show the below equation? Yeah, yeah, yeah. And the
One,
diagram also. Diagram
one
also.
small clarification on why it is minus 1.5.
No, they have given the bias as like that. The minus 1.5
Now,
as
the
threshold.
equation we have 2, I understand 2 into x1 plus x2 minus 1.5. How come minus? Why not plus?
That is a threshold they have given, right?
Okay.
Okay, it is -2 means everything minus has came out. That's why this one has plus. Becomes
Ah,
minus.
okay. Minus overall, they're taking it out. Okay.
Yes, yes.
So the first neuron, that is the 1.5, right? That is the threshold, right? The first one.
Yes, that is the threshold.
Yeah. And its weights are 1 and 1, right? Okay.
It's a 1 and 1. Yes. That's
And the
why
sec
this, yeah.
and the sec what is the W there? Sorry, I'm still trying to understand the W on the x1 to the last neuron, right? Which has a threshold of 0.5. But if you see the weight x1 to x1 to 0.5, the weight W, that is something we have to derive, right?
Yes.
Yes.
Okay.
Greater than or equal to 0.5, the output that they are equating. Okay.
Yes.
I
Oh,
it
so
is
then
multiplication minus 2 into.
Welcome, Rao.
Hi. There, but I'm getting why it is minus 2. There is a multiplication.
Yes.
1 x1 plus w minus 2.
can you please explain one more time? I'm still trying to understand the solution they're given.
Yeah. In general, how do we represent a perceptron means yeah, a neuron, right? So it's a W0 plus W1 x1 plus W2 x2, which is greater than or equal to something, right?
Yeah.
So with this one, we have to identify what is W here. Okay. Given that this x1, Wx1 plus Wx2, so which is going to 0.5, the first one, minus this one, which is a threshold. Again, it has two thresholds as such, x1 and x2 has to be multiplied with two factors, right? for the output and the in middle threshold. Probably I'm also just trying to understand the solution what they have given.
Yeah.
And now
I mean, it's not solution, but at least if we understand the approach towards the solution also, no, that will help, right?
Yeah.
so now I got a little in. So they gave input that equals to bias is one, and in the circles they gave error. Uh,
I
if you
think.
write for,
Okay, go on, go on.
and if you write this first one, x1 x1 w, usually the product weight multiplied by the inputs and sum of all weights multiplied by 1 plus w to that's
I think, yeah, what my understanding is, since it's a XOR, right? They have taken just an example like x1, x2 would be like 1 0 or 1 0 1, and then expectation like output expected is 1, right? And accordingly, they are putting the values, it seems.
that is correct. We have to apply the values all the table like 1 1.
Mhm.
So all the permutation combination of 1 comma 0 and 1 1.
Mhm. I'm still trying to understand that third term like minus 2 and the bracket
Yeah.
x1 plus
So
x2.
let's say, yeah, let's say if we divide it, right? How will it come? The output of the first one goes to the as an input of the second one, right?
Correct, correct.
So when you check the output of the first one, it is x1 plus x2 with some threshold. Okay. Let's say you have got an output of some x, but
Uh,
the output of the minus 2 term also inclusive of the threshold and x1 and x2, right?
Understood. Correct, correct, correct.
Right.
So it just they given instead of what step by step, just in one shot that's mentioned.
Mm, yeah, yeah, yeah.
Okay, it's clear to me. Yeah, yeah, thank you.
So
Manoj,
Yogesh,
you are clear?
Yogesh, can you explain me how is this done? Because
Okay,
yeah,
okay, okay.
what is a requirement?
See,
We need to find W, right?
yeah, yeah. Let's go one by one. See, if you see the first neuron, right, the very first circle, which has a threshold like 1.5, correct?
Yeah, this one. Yeah.
Let's yeah, that one exactly. So that's the bias component, right?
Mm-hmm. Yeah.
So if you see here, what how we calculate, right? It's a W and X combination, right? Like a multiplication, right?
Yeah.
So
Yeah.
W1 X1. Here the W is 1.
Yeah.
If you just focus on the, yeah, W is 1, right?
Yeah.
So X1 into 1,
Yeah.
that is 1, right? I mean X1
So what is the
plus,
input? What is the input? Yeah, 1 0.
yeah, X1. So I mean
Okay.
you can take any input like 1 0 or 0 1, but just to I'm trying to first explain the approach, okay?
Yeah.
So first, just focus on the first neuron,
Mm-hmm.
which is having a threshold of 1.5,
Mm.
and just calculate the z value there, right? Like x1 w1 plus x2 w2
Mm-hmm.
plus w0. I mean bias here is nothing but 1.5,
Mm.
right?
Yeah.
That's okay, right? And then now you will use this as an input, right?
Mm.
And then you're passing it to the next neuron, which is having a threshold 0.5, correct?
Yeah, but here we are not adding the bias, but we are just checking the bias like input is greater than bias, right?
Yeah, they just took a bias left hand side actually.
Hmm.
Yeah, and then if you see the output of this one, right?
Yeah.
Again, this output, it is multiplied with the weight there. Weight is -2 there.
Okay, so yeah, does this equation belongs to this one like wx1 plus wx2 minus 2 x1 minus 2 is what we have here.
Yeah, if you see that they are trying, they have given like just one direct equation. I mean, so if you see the weight if you look like focus on the final neuron, right? The
Okay.
weight is given, right? W, right? If you see the weight x1 to point, that W. So x1 W1 plus x2 W2,
Mm-hmm.
and then the output of the hidden neuron.
Oh, okay, okay, got it. Yeah, yeah, that's
Yeah,
nice.
yeah,
Yeah,
that's
yeah.
how. I mean, I mean, we can try on our own, maybe step by step. But this is my understanding, as I think Pradeep or someone explained, right? This is like I understood.
Okay. Yeah, yeah, fine, fine. So it comes here to minus 2 into x1. Yeah, because
Yeah,
this
yeah.
is 1, so
Now,
x1 plus, yeah,
This is
they are.
for
exactly,
input 1 0. Like they are assuming two input.
exactly. If you see, yeah, if you see the bracket term, right? Just see bracket term is nothing but x1 into 1 and plus x2 into 1. Just see now the first neuron, right? See the weights are 1 and 1, right? That's why you are not seeing there. They just, if you just say
Right,
2 in
right, right.
bracket should be like x1 into 1
Yeah,
plus x2 into 1
Yeah,
minus 1.5.
minus
Then you will,
1.5.
yeah. That's
exactly,
clear. Yeah,
exactly.
that's clear. Yeah, but 1 minus 1.5 is a little bit confusing here, right?
No, that is the bias term as such. The
Yeah.
minus has come up because, see, in the equation, what will happen?
But x1
If you
plus
equate,
x1 plus
right,
x2, you should be
that
greater
greater
than.
than or equal to 0, when you come bring it to that bias to the left hand side,
Yeah.
it will become a negative sign,
And here it
Mm.
right?
will be what, 0 or what? So when it goes to this side, what will be here actually?
Yeah, assume it is 0. It's
0.
a some mathematical inequality kind of thing. Assume we can assume it is 0.
Hmm.
I was thinking
But
that
it's
one, why it
mentioned
is minus 1?
0.5.
Because W0 x1 plus W2 x2 plus bias term here, which is here plus 1.5, right? Actually equal to 0, correct? Why minus 1.5?
Okay, it is minus 2 into this output of this one, right? Minus 2 into 1.5, okay, of the previous terms. How much we have? X1 plus x2 minus 2x1 minus 2x2. What I think is,
Mhm.
yeah, in general, let's say we say something like x1 plus x2 is greater than or equal to b. Okay.
Hmm.
Now we say x1 plus x2 minus b is less or equal to 0 or some other number. If you remember our MFDS sir, Deepak sir used to say our simplex problems, right? There, even though we have that greater than inequality, we bring to the left hand side and equate it to 0. That is what it is done here. I must have complicated it. Yeah, but
Yeah, I understand that simplex
yeah,
problem.
we have to, if it is a negative on the right hand side, okay, move it as a positive to the left hand side and equate to 0.
No, no, what?
No.
Yeah, so because 0.5 will also be negative inside
Yes,
multiply by
yes,
plus, yes, the both the side,
yes,
yeah.
Can you say again, because it's a bias term we add, right? So x W1 x1 plus W2 x2 plus b equal to 0, correct? That's how we calculate the z value, correct? And
Oh, okay,
no,
then
okay,
plus
okay.
b
Yeah.
is greater than something.
Yeah, I got it. I got it now. Yeah, because we are this 0.5 is this bias time actually.
Yes,
So
that
we
is
are,
last
correct.
bias term.
yeah. So we are
That is
just,
that is last. That
hmm,
is last one.
yeah, right. This last one, yeah. So it has to, the all the inputs has to be greater than or equal to
Then
0.5. Yeah.
then
So
if you look at the bracket term, right?
yeah.
X1 plus x2,
Hmm.
why it is minus? I'm still like wondering, because it should be plus 1.5, right? In that case.
Yeah, because in this one we are having input greater than or equal to bias is output will be 1. So
Okay, you can think in other way. It is minus 1.5, right? Here you added minus 2 into minus 1.5, which becomes plus 1.5 on the right.
Sorry, can you say again? Two is a weight.
This minus 2 is multiplied by x1 plus x2. Okay, plus 1.5 you are saying.
Yeah,
That's what you are.
just yeah, exactly. In the first line, the bracket term x1 plus x2. I'm thinking x1 plus x2 plus 1.5.
Yeah, actually, Yogesh, what you're saying is right, but in this one,
Yeah.
the activation
Mhm.
function is slightly different that normal mx plus b. Here we are
Yes.
having mx should be greater than or equal to bias. Bias is on the right side. They have specifically given this one. That's why we are not making it plus. So when this bias
Okay.
time is given on the right side, then we have to bring it to
It
the left side. So then it will be minus.
needs see it's a plus 1.5, right? Equal to 0. Now say you take a bias to the right hand side, then it will become minus 1.5.
Yeah, bias to the left side. Yeah.
So, but okay, I just need to again. I will do it again, like
Because in the
just to
normal,
understand.
Maybe we can try it out for another example. Yeah.
Yeah.
yeah, because in the normal case, what you're saying is right. Mx plus b. That's the formula you are saying, right? It should be plus, right?
Yeah, yeah, because it's like WX, W1X1, right? Like WIXI
Hmm.
plus bias term.
Yeah, but here they have specifically mentioned it's not plus bias. It is equated with the bias, and if it is greater than the bias, then output will be one.
The output is 1 when the total
Hmm.
input is greater than the
Yeah.
bias.
So x1 plus x2 is what is here, right? Because the weights are one. So it's
Yeah,
x1
yeah.
plus one plus x2. If it is greater than or equal to 1.5, then the output is one. So that's the
Okay, 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 okay. Otherwise, it won't
yeah.
fire. Okay, okay. Now I got it. It should be plus 1.5, but just to fire it, we have to make it minus 1.5. You are saying, right?
Yeah, right. Yeah.
Yeah. Otherwise, yes, it won't fire it. I mean, its output will be 0. It's not 1. Yeah, yeah.
Hmm.
I think that sounds good. Yeah,
Yeah,
clear
yeah.
to me.
This is
Thanks,
a bit
Yogesh.
It's not a normal one. It's a bit different. But this you will find it in many places actually.
Yeah, because yeah, the output should be 1 only when the input has to be greater than bias. Okay.
Yes, yes, yes. So still then, so this is one option. This is the second option. This is the third option. This is the fourth option. I think.
And why they put a 0 there? Oh, okay, 0. Okay, they just took a one example, right? 1 0 or 0 1. And they just put the values there
This is
and
the
yeah, found
values they
out W.
substituted.
Okay.
Okay, this is a substitution of the values. Okay. So
Yeah, yeah.
yeah, so it should be minus because it has to be greater than this one or equal to.
Guys,
Yes.
I'm dropping off. Thank you.
Okay, all the
Okay.
best. Yeah.
Thanks.
Thank you.
We should start a bit early tomorrow, Manoj.
Yeah, we will start 10 p.m. IST because that's your time, right? I am available before that also.
Yeah,
Uh,
tomorrow also I will be available a little early. I will be at home, so
Yeah, Praveen, what is your time? Maybe we can start at 8 p.m. UA time. Hmm. Okay, we can start anytime. I am available in the evening.
Yeah, didn't sleep. That means tomorrow I have to wake up early. I have something to do. That's
Yeah, yeah. In the India, is this time is now 12 o'clock. For me, it's
yeah, it's
me
little
and
late.
Praveen. It's 12. I mean 10:30 now. Yeah,
okay. All of you are out of India, huh?
not all, but
Not all, yeah.
Yogesh is
Oh,
in UK. What is your time, Yogesh? There?
My time is I'm in Netherlands, Amsterdam. My time is 8:30 p.m. So I'm good actually because I'm
Hmm.
3.5 hours. Okay.
Yeah.
But tomorrow I will be at home, so I'm thinking I can join early. I mean,
better
we can collaborate, Yogesh, just to make the writing of the problem.
sure, Praveen. What is your ID? I mean, Beats
Sorry,
ID. Like, your Beats
sorry,
ID.
my bits ID. Okay, I've already pinged you in bits. If you remember, that's for the big data. Big. Okay, let me just.
Oh, okay. Can you please again ping me again? I might have, because there are so many pings actually. Sorry, I couldn't.
Okay.
I can ping you. Yeah. You just ping me on WhatsApp or in the Teams also, and then we will try, and then we can collaborate.
Yes.
Yeah, that sounds good too.
Yeah, some people were asking me your phone number and all. Yeah, Yogesh.
Phone number? Yeah, my phone number. Okay, let me give.
Yeah, I sent them. Yeah, actually, the WhatsApp.
Yeah, it's fine actually, because during after this last BDS and couple of sessions, some friends reached out to me directly also on WhatsApp, and also I tried my best to help them out.
Oh, that's nice.
It is fine. Yeah, I will try my best. Not a problem.
That's nice. Yeah. Okay, so are we continuing on this, or are we stopping it now, or what? We can continue, right? So yeah, so we got this equation. It should be greater than 0.5 for the output to be 1. But what's the
Manoj, you are not sharing, I guess. Can you please share?
Oh, sorry.
Yeah, it's okay. Yeah, because the session is started fresh, right?
Yes.
Yeah, Praveen. Okay, thanks.
Got it.
Yeah, got it.
Okay, so what we are doing is this is the equation to get an output of 1, right? But input, if XOR, this is XOR that we are trying to. So XOR output will be 1 only when the both inputs are 1 or both the inputs are 0, right? So for input 1, 0, how can they do this one?
No, Manoj, I think if both the inputs are 0, it is 0. Both the inputs are 1, it is 0. So 1 and 0, that comes.
Yeah. I mean, both inputs should not be matching. You see here.
Should not be matching.
Yeah. Okay. It's a 1 0 or 0 1.
That's the special about XOR.
Exactly. Yeah.
Okay, I am talking about maybe XNOR then. Yeah, I have to refresh.
Yeah. Okay. But again, no, these things I don't know. They will give directly. So if they just give XOR, no, we have to mention this, like,
I think I have sent all the XOR whole link I've sent in one of the channel. I don't know.
Okay. Yeah.
That's a nice channel.
Just to sidetrack, actually yesterday I was solving some question or something, and I came across about this Hessian matrix, right? And then using that Hessian matrix, we do calculate the lambdas, right? If you guys remember. And the topic was, how do you find whether the given point is global minima or global maxima, correct?
Yeah.
So that question actually I did solve. I understood. Probably tomorrow when we get time, I mean maybe at the end, I will just try to show, and also I will try to explain, and then we can see if my understanding is correct, or that way also. Because what I found was that required us. I was referring my mathematics notes, like a first semester. There, if you remember, there was an example given a matrix, and using that we formed out the characteristic matrix, then the cubic function, or that function equation, and then
the summation of x square, x cube linearly, and
exactly.
Okay.
Exactly. Yeah. And then when we solve that equation, we get the values for lambda. So lambda.
Yes. And lambda. 2 lambda will come. 2 lambda.
Exactly. Will come. Okay. Exactly. Depends. Yeah. If it is a cubic equation, 3 lambdas, right?
3 lambdas. Okay.
Exactly. Okay. And then at the end, if you see the values of all the lambda is positive, right? So everything is positive. Then you can conclude, since the all lambda values are positive, the given point, whatever point you have derived, is a global minima. Because you remember, right? Minima, how do you calculate minima? First derivative, you will get minima. But
Yeah.
whether it's a global or not, global or not, you just do a second derivative, correct? I was,
Yeah, correct.
yeah, exactly.
But
So
I didn't recall that we've been doing that one for this one.
because I
Okay.
think when I was going through the lectures, he took that example in the lectures. He didn't explain in detail. Then I struggle a lot to find out. But at the end, I thought I understood. I have made my notes. Probably tomorrow we can discuss that too, because I think that is a probable good big question, because you have to first calculate see, they have given an equation. Okay, so you have to you have to calculate the first derivative, then the second derivative. Okay,
Yeah.
then solve it, and then decide whether it's a global or not, like that. So it is also a possible question.
Nice. So there was another Max professor in the second one. He was teaching good actually. It was a YouTube I was watching continuously. Was a guy. It starts with the D. The professor, I think. Panimalar
No,
also knows.
I forgot his name. I mean, somehow I was able to understand his.
Deepak.
Okay. For us, the lecturer was different actually, but he was also good. Yeah. Yeah, but again, like coming back to this point, Manoj, we can continue. Sorry to take you this away.
So actually, I put a link in the Teams channel. Anybody interested in and or mixing and or XOR anything, you can take a look of that. So this link is pretty much
okay, cool.
A very good understanding of all the gates.
Yeah.
And or not XOR and XNOR.
Yeah.
In the perceptron.
Because it is a high chance that they can just only tell the XOR. They will not give the actual values, right? They expect us to mention if it is inputs are 1 0, then it will be the 1.
Because the best part in that link is the prediction of y equal to wx plus b greater than 0, wx plus b less than or equal to 0. So they have given that prediction algorithm in that link.
Yeah, I'll also make a note. Thanks, Praveen, for sharing this too. Yeah. Good to have it just a single place. Yeah. And one more thing, what was that?
What's the next problem, Manoj, in this one?
Yeah, we can continue. Oh, that problem you were discussing, right? This minus 2 into...
This we need to apply all the tabular column value, so that like 1 0 0 0 anyway 0 0 is anyway 0 only. So 1 0 0 1 and 1 1. Scroll down, Manoj.
That's done, I think.
That's done. So next the fourth question. Okay, yeah. Okay, great.
So why this became 2.5 here and less than 1.25? 2 W's this time.
Oh, they tried to solve it actually. Yeah. See, they took example for x1 equal to and x2 equal to 1. If you put those values, you will get that equation, and if you solve, you will get a w which is less than 1.25.
Oh, this 2 became on the right side, came to the right side plus 2, right? Yeah. Then w, then 2.5 divided by this 2. Yeah, that's why it came like this. Yeah. W should be less than 1.25 or equal to. Yeah, that's the smallest.
Yeah.
They are asking the question like what should be the smallest value of W?
Mm-hmm. 5.
Yeah, this is a different question actually, right? What is the smallest value of W that can realize XOR? Yeah. So this W we can vary these values of these two, and it should be both same. And we found this is the equation, and then we are substituting the here the W should be greater than or equal to 0.5 when the input is 1 0 or 0 1, and when the input is 1 1, the output has to be 0, and we found that W should be less than or equal to 1.5.
Because your output expected here is 0, correct? because you have taken the x1 and x2 both are same, which is 1. So your output with this input to XOR is going to be 0. Above you see above the output is 1 because the values of x1 x2 are not same. Either you take 1 0 or 0 1, and then output of the XOR will be 1. But the second example, they have taken the same values. You take either 1 1 or 0 0, then output should be 0. But I think these things now we understood, right? It is good to like do it on our own also, just to be getting some kind of hands-on experience. So it will be easy.
Yeah, because anything which goes in the minus level cannot be realized. W equal to 1.25 is the smallest value of W.
Correct.
At which XOR cannot be realized.
Exactly. Yeah.
Okay. Right.
So, but
we-
here the W is less than or 1.25. Here W is greater than 0.5 or equal. So the minimum should be 0.5. No, why it should be less?
No, 0.5 is in the
less,
greater
right?
range, no?
Yeah.
Sorry, what?
W is greater than or equal to 0.5. Here W is less than or equal to 1.25.
So they are asking the minimum one. So it should be 0.5.
Exactly.
The answer, right?
Yeah, that's the reason. No, yellow highlighted says 0.5.
Oh, okay.
Yeah. So I mean, by taking both examples, we see W is minimum is 0.5, right? In the second example, it can be something, but it should be less than 1.25. But from the both values, it is clearly visible that W is minimum at 0.5.
Yeah.
It should be minus 0.5, right? Minus 0.5. Am I audible?
Yeah.
Is greater than or equal to 0.5 from the first 1, 0 or 0, 1.
Okay. You're saying that plus 1, if we take on the right, it will be minus 0.5, right?
Yeah.
Let's solve this equation. Probably like W plus 0 minus 2 plus 3.
I think something to do with greater than or equal to Rao, because if it is not directly equal to based thing, no, this is something. If it is equal to, yes, the symbol change. If it is the different symbol, because even in the down, if you look at 2W minus 2 less than or equal to 0.5, 2W is still there. This 2, if you take in that side, comes 2, because it's in the different direction of less than or equal to, right? Something to do with that?
Hello.
Hello.
Yes, I think this is the reason. Prachi, this side.
Yeah, Prachi.
So I think because -2 we are taking on right hand side, no? That's why sign is changing. I think the third statement in the third line where they are placing grade less than equal to, they are changing from greater than equal to less than equal to. That I am not very sure, but in the fourth line where 2W less than equal to 2.5, here symbol is less than equal to because we are substituting -2 to the right hand side and it is becoming 2.5.
Yeah, the symbol change. Yes, that I understand. Second equation. The first equation, W plus 1 greater than or equal to 0.5. That is where this 1 goes on the other side.
Yeah, W should be minus 0.5 only, yes. Otherwise, that equation will not hold true, right? If it is 0.5.
Or possibly here also it should be changed in the equation, but it might have not changed. Instead of greater than, it should be less than or equal to.
No. there in the first set, right, 1 comma 0, 0 comma 1, XOR should be fired, output will be 1 only when W is greater than or equal 1, complete output will be greater than or equal to 0.5. That's the condition to be met. In case of second, when both inputs are 1 comma 1 or 0 comma 0,
Yeah.
it will be less than 0.5, the whole perceptron to get fired or XOR gate to be get fired. That's the condition. So that's why less than or equals to 0.5.
Yes.
But so why it is greater than or equal to 0.5 in the first?
Oh, because first, if you see, right, first one you are expecting output as 1, right? Because your input is 0, 1 or 1, 0. So the XOR output you are expecting is 1. When it will become 1? When your output is greater than or equal to 0.5. I'm assuming they're using the which function? Like 0.5.
That also they gave Yogesh in the question itself. Input greater than or equal to bias. They clearly gave. So total input calculation greater than or equal to bias, it will be 1. Otherwise, with that condition, it should be greater than or equal to 0.5 in the first set. 1 comma 1. Only thing is it should be greater than or equal to minus 0.5. After the computation, minimum value of W should be minus 0.5 is what?
Correct. Yeah. I also see that a simple, right? Like a +1, if it goes on the right, it will be minus 0.52.
I'll do one thing. Tomorrow I'll just cross check and substitute values, and if I get something, I'll share.
Okay, that's good.
Minus surface.
Which one? This one?
First one, part A, the first part he's saying.
Yeah.
So they have given like W is greater than or equal to 0.5, right? But we think that it should be minus 0.5. W is greater than or equal to minus 0.5.
Minus 0.5, but then how will it work? Because then minus 0.5 x1, that will be minus 1 here, right? And this is 0. Okay, so minus 1 minus 2
minus 0.5 minus 0.5 into 1 minus 0.0.
No, Manoj, if you see the same equation, if you see the third equation, right, W plus 1 greater than or equal to 0.5, right?
Yeah.
And if you try to solve it, you are taking 1 to the right hand side, right?
Okay.
Then it will become minus 0.5 right there.
Like,
minus 1 plus
that second step only, yeah, like here the minus 2 we are taken into the bracket means, so at the time minus 2 plus of 2.5. So like at the time so minus 2 plus 2.5 we are getting plus 0.
Actually, you know what? This kind of thing, no, we should have that what we call it as, where we can, write on the screen, right? The way professor show, right? It is easy.
Yeah, actually myself and Praveen is having that. I am too lazy to use that one actually.
Oh man, you have it, right?
Yeah, we already purchased for this combined study only, but
yeah.
But
I think this is useful.
Manoj, I'm using that in the office actually.
Oh, nice.
You can try this, Praveen, because that way now you will be able to write, and it will be easy for everyone to understand also.
Yeah, right.
Here they're talking
I'm thinking, Rao, if you look at that first equation, minus 1.5 should be plus, and then when you take in the other way, then it becomes a minus.
So see,
we all been discussing that minus 1.5, no, or the first equation itself. Why can't it be plus 1.5?
No, not plus 1. Oh, okay. No. That was clear.
Yeah, the output final line, right, Rao? The last line.
We already solved the equation, Praveen. So the final equation is W plus 1 greater than or equal to 0.5. So till point everything is clear. Why it is W plus 1 greater than or equal to 0.5. But now simply now send the 1 to right hand side. It
Yeah.
will become W greater than or equal to minus 1.
Yeah.
So that portion alone, uh, why they have not, even though it's coming as minus 0.5, why they did not take it as minus 0.5? That thought alone.
They indirectly ignore that one here.
Yeah, they indirectly ignore that.
Yeah. You got it right, Praveen? See the last but one the line equation is W plus 1. It is greater than or equal to 0.5, right?
Correct.
Now, if you take that 1 to the right hand side, it will become minus 1, right?
Yeah. I'm
Yeah.
getting that. Yeah.
Okay. Yeah. So that's the one actually even I see. So in that case, then it will become W greater than or equal to minus 0.5. Then the minimum value of W, it would be zero point 0.5. Sorry, minus 0.5 then.
But
Yeah,
one thing, if I don't know whether they are taking plus one to that side or not, because sign changes when we take any value to the right hand
So
side.
here itself we can get the solution 1 minus 1.5 what we get zero point 0.5. So
Minus
yeah,
point 5 we will get minus
minus
point
zero point
5
0.5
into minus 2,
minus
that will be
Exactly.
0.5
1
into
only.
minus 2, yeah, that is
That
1.
that is plus 1 only. But
Yeah,
that thing, if we will take plus 1 on the right hand side, then it would be minus point 0.5, na?
Correct.
Any.
That's what we were thinking.
So
Yeah.
I
Yeah.
am thinking sign also changes, na? So they have not changed the sign also. If they have taken 1 to the right hand side and subtracted from the point 0.5.
Yeah. That's the reason actually we are thinking it should be minus zero point 0.5 on the right hand side there.
I am thinking they have neglected plus 1 in the last equation.
Yeah, probably we have to revisit and check to confirm exactly if this is correct or if this is just mistakenly minus is not there.
Maybe.
If you put okay, let's just try to put this value and check W is greater than or equal to 0.5. No, if you put the value, what will be the output? We can use this one, right? W plus 1. For example, let's take W. Let's take W is equal to should be greater than 0.5. So 0.5, right? Then we'll
I think
take,
we park this one, Manoj. We move on.
Yeah.
Maybe
Yeah.
because we spent so much time on this. Yeah.
We can do this offline. Maybe tomorrow we will
Offline,
come
yeah.
back just to, if someone finds out exactly what is the correct and how they have done, we can just quickly discuss tomorrow. Maybe the open item this tomorrow like that.
Because the next question is also interesting, which is a loss function. We have to do the differential calculus. So the let the loss of x comma y equal to an equation. What is the value of x option, y option that minimize the loss if L1 regularization consists constant 0.1 is applied? So the explanation is from the given loss function, we have to make the differential calculus of the equation. So d loss of x comma y divided by dx. So with respect to x and keeping the y as constant, we have to do this 2 power 3, so it becomes 6x minus 6, keeping 3 and y as constant. Then again we have to do the differentiation with y, then all the x is constant, then 2y. In the unregular case, the solve the equation, so we need to apply optical to 1 and optical to 0 for the regularization case. So this part anybody understood?
Yeah. For first the derivation I understood.
Yeah, derivation understood. Here, this bracket of max and things I haven't listened through. So this comes in a max equation, plus and minus. Rao, any idea about this one?
This is again Hessian matrix, right? So
Hessian matrix, right?
Which matrix? Hessian matrix?
You were saying, right, Yogesh, the second order derivative we will take. Because first
Yeah.
So we again need to do this one as a second order derivation. So with respect to, that's why we are doing the d square. If you scroll down, Manoj.
The below, right? Yeah,
Yeah,
6
yeah.
and
So
0.
d square. Yeah, d square loss of x comma y dxy equal to 6. So second order derivation. And again, with respect to y we do, then it becomes 0. Then again, what they're doing, d square loss of x comma y dy square.
Is it a ReLU function there?
Yeah, we have to find H11, H12, H21, like we have to form a matrix.
Ah,
Okay,
so
what I can do is, I think the way I was mentioning, right? Yesterday there was a similar example. Probably I can give a try, and if I see the exact same thing, and if I see that it's matching, I will explain tomorrow. What do you think?
So
I mean,
so particular this H11, H12, right? So how
Yes.
they are forming that in that derivation to
Um,
be, yeah.
yeah, dou square x divided by I think. Huh. Like let me take this tomorrow, Ji.
Fine.
Like it is my max note. It was available. I will.
Okay,
yeah,
then
I think
we'll
I
The step by
can.
step answer I will take tomorrow.
No,
okay.
derivations I can explain because to get the h11 term, right, you need to again
Yes.
Yeah.
take a partial derivative with respect to x. So 6x
Okay.
we already got it.
This got it. Okay.
Do it one more time with respect to x. So that will be
This to x or y.
no. First, dou x square means with respect to x again. H11 term, right?
Hmm.
It's a dou x. We already took the dou L by dou x, which is 6x minus 6. First order derivative is already taken.
Yeah,
Right?
first order is 6 minus 6, and first order y is 2y. Yes.
And now you apply for H11, you apply the second order, again you derive one more time for the 6x minus 6 with respect to x. So that is 6.
Yeah.
Oh, but if you see the second,
The zero,
right?
how it comes 0, h1, h2,
No.
1.
Oh, because you are not doing dy, it is dx dy.
Correct. So H11 is 2 times with x actually. H12 is first with dou x and second time it will be dou y. So if you do 6x minus 6 with respect to y, x is constant, 6 is constant, so it is 0.
Okay.
And H22, which is a dou L by dou y. So that means
Right.
the y, you do it with y again. So you will get
2 times y. Okay, that becomes 2. Okay. All right.
Yes,
now let's
yes.
take H21. H21 is 2y with respect to x you need to take. Dou x L by dou y you already do. Dou L by dou y, dou x. 2y with respect to x, it's a constant. So y is a constant, so it's again 0. H21 and H12 is 0.
Yes.
Yeah.
Okay,
General,
nice.
yeah. General formula H21, H12, you will get 0 if there is no xy terms. It's
Correct.
simple. As long as there is no xy terms in the equation, if there is no xy terms in the equation, H12 or H21, any combination will become 0. But only thing is, this is what is called Hessian matrix: H11, H12, H21, H22. If you put it in a matrix form, that is Hessian matrix.
Correct.
Only complexity they have added is they have added L1 regularization.
What's that? L?
L1 regularization.
L1 regularization constant they wanted to add.
0.1.
Okay.
How they are going to use that, I'm not sure. If you go to the down again.
Okay, that is max of 1 minus. Okay.
Oh, where that when one came from? Yeah, minus 1 minus point.
That's a regularization
No.
formula.
Point 1 is the what? Okay. No. This you see this max of 1 minus.
The max of is the formula. Okay, it's coming from the L1 regularization.
Okay, but where that 1 came from? 1 minus, right? What is that?
Yeah,
1?
that's also part of the formula.
Oh, that's a formula constant. Okay.
Yeah. some regularization is there. Uh,
So 1 minus whatever the constant, that is 0.1, divided by h11. Is that right? For x opt, for
That
the x.
that to me actually.
In the question also 0.1 is applied. If Elver regularization constant 0.1
no,
is
that
applied. So
yeah,
that
0.1 is
0.1.
the lambda that we applied in there. So the
Yeah.
regularization function is, I think, they have given theta square. This is the formula, I guess. The max of it's a regularization formula.
Oh, see, there, see. Actually, if you see the formula above given,
Yeah.
lambda, which is given as
No,
0.1.
that's not a formula. I mean, actually, that is something we all to put in. It's
Yeah,
not given in the question. It's not given in the question.
yeah, I
So,
know it's not given the
uh,
question, but we have to
yeah,
remember
yeah,
and put it, and then we have to put it
yeah,
the
yeah, yeah.
formula.
Ah,
Yeah,
okay,
yeah, yeah.
okay. Yeah.
But I'm just trying to say, I was wondering, right, why, how did they put values? But
Right.
theta is nothing but 1. I have to again find out how it is 1. So 1 minus 0.1 is nothing, lambda is nothing but 0.1. And HII, here HII for x is nothing but x 1 1. Because if it is, they have given 6, right? So
The theta, I don't know why they have taken x opt equals to 1, y opt equals to 0.
yeah, but if you see for the second term, y opt, they have taken theta as 0.
Correct. Because y opt is taken as 0.
So is it always the 0 there?
No. After the first order derivative, they made some one assumption in unregularized
Okay.
sense for x equals to 1 and y equals to 0. That condition, why they took the assumption.
Oh, I think no. See the question in the regularized case. Solve the above equations. Bracket x opt equal to 1 and y opt equal to 0. Is that the reason that they have taken 1 minus for x opt, and for y opt it's 0 there, 0 minus?
In the question.
Yeah, see the question just above the formula. In unregularized case, solve the above equations. Oh no, that is the okay. That is not a part of question. It is again explanation part. Sorry, my bad.
Assumption they took it.
Yeah. What is the value of x opt and y opt that minimizes the loss? Oh, is it something x 1 and 0? Why they took 1 and 0?
Lambda is an hyperparameter. Okay.
Yeah.
Lambda is given fine. H11 and H this H also we computed.
We computed, but how did they get considered x opt as 1 and y opt as 0?
Some initial values they took. That's what is.
So they mentioned solve the above equation, but on which basis they are saying x opt equal to 1 and y opt equal to 0? That's thinking 0. They are taking. I think that's it. That's it. That question.
That's the fourth question. Finish.
Yeah. On the same page, same screen. The fourth question finishes.
So this one, who told will check it? Is Shankar told or what?
Yeah. I'll check.
You will check this one, right? So okay, for you have two questions for tomorrow, right? One is the next question and this one also.
Question.
Yeah, probably Shankar, you can solve this with your own knowledge also. I'm not sure if this is correct or so, but just see. I mean, we currently understood and only stuck on why it is W is greater than or equal to 0.5 and not 0.5. But see, if you have another way, that might be the right approach.
So I think
Can you go scroll down?
This
Manoj?
Yogesh and Praveen will solve. This is solved.
Yeah.
Yeah.
Second will
So
solve.
I have put it in the group. Okay, who will be solving what you already accepted. It's okay. I'm just for the reference. Yeah. Guys, actually, I need to leave now because I need to get up at 4:30 now. It's already 11, and yesterday also. Can we meet tomorrow, or we need to continue now? What do you think?
Yeah, that's okay. So this max function will continue tomorrow. Yeah, because
Yes.
the fifth function is also the same, just the
Mm-hmm.
derivation. But again, there is another loss of formula. They applied L2 regulation. So we need to
L
study what is L1 regulation and L2 regulation. Then these two problem could be solved.
Probably maybe tomorrow we'll solve, and probably we will
Yeah,
just go through the lecture to understand more
yeah,
about
yeah.
it.
So regularization, I haven't touched it. I need to go through the
Same here.
videos.
Yeah.
Okay, okay, okay.
This is good. This is really helpful. Thank you,
Yeah,
guys.
yeah. Thank you
Yeah,
so
yeah,
much,
sure.
everyone.
Because
Yeah,
at least we can solve each other. That's
yeah.
easy.
Yeah. So Praveen, we'll connect tomorrow then.
Yeah,
Yeah.
sure. From office also, I will be working something, so I will
Uh-huh.
connect.
Fine,
Nice,
fine. I
nice.
will be at home.
But I cannot
So
take a call, but I can be working
no,
with
no, no.
you
We
in
will.
the
Yeah,
chat.
yeah.
Yeah,
Do one thing.
yeah,
No, we will solve. You can when you find time, you solve it. I will also solve
yes.
it, and then we will
Okay.
just connect and see if our answers are matching. Then that's
Mm-hmm.
it. But if they are not
Oh,
matching, then we definitely have to see who is wrong and how it is to be corrected like that.
correct. Yes, we'll
Yeah,
do
yeah.
that. We'll do that.
Okay. Cool.
Ji, I got that computational graph, some hint on this link I shared through chat.
Okay, where? And WhatsApp?
Teams chat I shared.
Teams WhatsApp. No, it is not. Okay.
Okay. You
Same
shared
question
one link.
available here,
Okay. Okay.
but not there detailedly solved the back propagation we have to do, I believe. Scroll down, G, like middle of the
Page. Okay.
content that contain this equation only we have.
Yeah. Yeah. Same
Yeah.
equation.
Oh, the same. Huh? Okay.
Share me the link in WhatsApp, Panimala, because I'm not seeing the
Yeah.
Teams.
Yeah, she has put in the Teams actually,
Teams
but this is
chat is
good.
okay. No, it's already done.
We will give a try. Otherwise, now we already have a solution for this, as
Yeah, right.
Panimalar shared. Yeah, yeah. Thanks, Panimalar, for saving our work.
this
It's,
can made continue.
Maybe they are going to try it out. So
this is nice.
Nice. Good one, Panimala.
But where is the manual?
So
This is all,
if you find something for L1, L2 and regularization, also share, okay, because
Sure,
that's
sure,
going to be
sure.
something that I haven't read.
Yeah. Yes. So.
Okay, maybe yes, Manoj need to go. Okay, we will reconnect tomorrow early, okay, as possible. Then we can, I think, a couple of days. If we do like this, I think we will be good for deep learning.
Yes.
yeah. So we will have then similar session for NLP after a couple of days.
Yeah, some of them not NLP, but we will take it alternately. But the Saturday whole day, if we can sit on DL, maybe morning to evening. We used to do for Sem 1, but if we do this one this time, will be good for DL, I guess.
But Saturday we have exam, right?
No, Sunday is what we have exam, I guess.
Sunday is DPN.
But Manojji has a Saturday also.
Oh,
yeah.
okay,
Some other subject. I think
Okay,
Manoj,
okay.
which subject you have? Other subject?
PGM.
Okay.
You guys don't have NLP on Saturday?
No, it's on Sunday only.
Sunday
Oh,
only.
okay. Anyway, in the Saturday 11 o'clock, I will be finishing the exam. So after that, I am available. Yeah.
Okay, great. I mean, if we just go through one day before the exam, that will be more effective than anything else.
How about now? Now we are doing good for DL.
Yeah, this is good,
How about NLP? Are we also planning to do NLP like this in a couple of sessions?
I am not in NLP, so.
Yeah, you are not in NLP, but those who have a NLP as a subject.
So we will connect. Okay, I'm in NLP. Yogesh, we will connect.
We will connect and we'll plan. Yeah. So
we'll
those
plan.
who interested, we can join. Yeah.
Because NLP, the ma'am has actually segregated all into 3 marks. Quite a lot of thing has done. The last lecture, she was telling where all it would come. So something on vectorization, it would come, IDF, it would come, something on normalization. So the pattern is clear for NLP.
Yeah.
We will
Vitaby and all that.
sorry. Yeah, vector B. So day after tomorrow we will connect for NLP.
Cool.
Yeah.
Okay.
So in the office I don't have any work, but I will connect in between for you.
Yeah, then maybe Wednesday and Thursday we will reserve it for NLP then, 2 days.
Yeah. Better.
Nice.
But Saturday
Nice.
let's preserve it for DL only. That will be good.
Okay, then I will just focus on next 3 days for NLP.